So, as we said, a polymer is made up of many, many units. Poly, the word poly means many, mer means units. And so polymer is made up of many, many units of one type of organic compound usually. So, or an alkane or an alkene or whatever. So, in the case below, here we have a picture of polyethylene. And polyethylene is made up of ethene, many, many ethene molecules bonded together. So the monomer is ethene. The whole big macromolecule is polyethylene. Many of your plastics are polymers, along with many of the fabrics like nylon, rayon, cotton is a natural polymer. So there are natural polymers as well as synthetic polymers. Think of a chain of paper clips, and each paper clip would be a monomer, but the chain altogether would make up the polymer. And sometimes your polymer can have different monomers, like you can have alternating monomers, or you have two of one type of monomer and then another type of monomer. Okay, there's two ways to make a polymer: by either an addition reaction, where you're breaking a double or a triple bond and adding the mers together, or by a condensation reaction where you release water when you're making the polymer. And we're going to talk about both of those. So on this slide, I know I have that it's an addition polymer, but this is all polymers are giant macromolecules. They're called macromolecules. They're not small molecules like the other ones studied. And as I've already mentioned, an example of this is plastic. Okay, so here we're talking about an addition polymer. In an addition polymer, you're going to be breaking a double or triple bond. Remember, that's what an unsaturated means. That unsaturated means there's a double or a triple bond. So you will break those bonds in order to put the monomers together. You can break those bonds, and then that allows you to connect the monomers together, like in polyethylene. It's not page 795. This slide was taken from another textbook, used with another textbook. But I will show you a picture of polyethylene. Alright, so I'm showing you a couple examples here of addition monomers. High density polypropylene, HDPE, is one example. A couple more examples of addition polymers are polypropylene. In polypropylene, the monomer is propene. And then polystyrene is a monomer made from styrene, which is a benzyl group with ethene on it. And that's the common name for it is styrofoam. Dow Chemical has patented that trademark name of styrofoam, but styrofoam is polystyrene. And just for your own use, you don't have to memorize this, but when you say phenyl, a phenyl group, that means it's a benzene attachment. Okay. Another famous addition polymer is polytetrafluoroethene, and as its name says, the monomer is a tetrafluoroethene. Okay. It's sometimes called PTFE. The trade name by DuPont is Teflon. I'm sure you've all heard of Teflon. It's found on non-stick surfaces, mostly in cooking utensils or pans. So as you can see in the names of these, the poly means many, and then usually this part of the tetrafluoroethene, that's what the monomer is. And tetrafluoro means you're going to have 4 fluorines on your ethene molecule. Well, they break that double bond in ethene in order to attach one tetrafluoroethene to another. Alright, well now we're going to look at condensation polymers, and these are polymers that are formed from a head to tail and it's usually accompanied by the loss of water, which is why it's called a condensation monomer. So you have water as a product in addition to the polymer as a product. And you do have a head and a tail on your monomer because you're going to be taking a hydrogen from one end and a hydroxyl group, an OH group, from the other end of the monomer. So here's an example of a condensation polymer is polyester. And the official name is polyethylene terephthalate, or PET, as opposed to PETE, which is another type of plastic. But polyesters, of course, are used in permanent press clothing. It's also used in tire cords. And on the next slide, I'm going to show you how this is made and releases water molecule. Now, you might have to zoom in on this a little bit, but hopefully you can see how a hydroxyl group from one end of the molecule is combined with a hydrogen from the other end of the molecule, and this makes it then allows you to bond the two molecules together to form the polyester. Why they call it polyester is not because your initial monomers are esters, but because once you've made the polymer, then you have esters that are formed. A polyester is formed from a compound that has two organic acid groups or carboxyl groups and two hydroxyl groups. Okay. And here I'm just telling you some more condensation polymers. You can make Nomex. Again, it's a DuPont trade name, which is a very poor electrical conductor, so it makes can make parts for electrical fixtures. You can make flame-resistant clothing for race car drivers, flame-resistant building materials, and remember the aromatic rings. Those are formed from benzene. Now, since we have so many different types of plastics, fortunately we are able to recycle them. And so there's a code system on the plastics that Emily did a wonderful presentation on. And the plastics can be broken up into 7 different codes as shown on this slide. And they can be recycled. And this just breaks it down a little bit, consolidates what Becky's slide was on. But that's what these numbers, when you see a recycle symbol, what the numbers represent is the different types of plastics. Now, these last 2 slides, I'm not going to quiz you on exactly when these different plastics were developed or anything like that, but I just wanted to give you an idea of the timeline of plastics. And some people would say that, there was the Bronze Age, there was the Iron Age, and they say now we are in the polymer age, the age of polymers, of plastics, because we use these so much. They're all over the place. In 1862 was the first synthetic or man-made plastic. In 1866, celluloid made its debut. Now, some people say the very first polymer that was made was bakelite in 1907. 1891, rayon was discovered. Cellophane caused the plastic craze. Okay, and of course we've come a long way since then. We'll continue this on the next slide. Okay, we see some more plastics that are familiar. PVC, as in the PVC pipes, polyethylene, saran makes its debut, which is saran wrap, plastic wrap. Teflon is discovered in 1938. Nylon stockings hit the market, and of course that was a big thing. And then Velcro, and I think Velcro was actually modeled off of an animal that they applied the same kind of has made up of little tiny hooks on there with the plastic. And we have incredible numbers of synthetic plastics. Now we have Kevlar, which is used in bulletproof vests and in Army helmets, very, very hard and resistant type of synthetic. So we are still making newer and better plastics, all with the properties, the specific properties that are going to fit a particular situation. And polymers are just wonderful.